The smoke object does a couple of things for you. Number one, it controls the overall quality of your simulation. And it also lets you preview and visualize the different fields that are happening within DOPS. So let's start off with the quality because that's probably the most important thing. Let's go to our render cam right here. And on the smoke object, you'll notice that whenever we select this and we go to this multi-widget tool over here, this allows us to control the size of this bounding box. And whatever's inside this bounding box is basically what the pyrosolver is allowed to think about. Anything that reaches outside the bounding box will either be killed or it'll bounce off the bounding box, kind of like hitting a wall or something like that. So the main idea here with this box is that you want to set it to whatever size is the smallest without letting your voxels hit the borders, unless you want them to bounce off or something like that. So I'm going to introduce a little bit of wind here in a bit. I'll bring this over to account for that. And then also in this Y direction, I'm going to bring this just past what our camera can see. Also on the bottom here, we don't need any voxels going down like that. So let's bring that up and then also check out the depth right here. Maybe bring this out a tad bit in this. And that should be about the right size for what we need. To control the number of voxels which are allowed to live within this bounding box, we have two settings, the division method and uniform divisions. And there are two main ways of doing this, the max axis or by size. We do have these other options, but don't use them. By size is probably the most straightforward. It's basically saying how large is every single voxel. And so if you were to picture a cube being made in 3D space and setting that scale to 0.07, you're basically just saying that every voxel is exactly that size. And that's how it's all figured out. If you go to max axis, what's going to happen is that Houdini is going to find the largest axis. In this case, I believe it's our X direction that is the longest of the box. And it's going to split up that box into an even number of segments. So if we have max axis and we have a uniform division of 250, it's slicing the X direction here 250 times and using that size to determine the size of all the other sections as well. I personally like using max axis, and I know a lot of other TDs like doing that as well. So I'd recommend sticking with that because it's just a little bit more predictable. And you also don't really have to be reliant on any specific scene scale that you're working with. So one other thing to keep in mind before I move on is that if you have max axis, let's say, and you have a bounding box that gets stretched way out here, now the Y direction is the largest axis, you'll notice that the quality of our smoke went down because, again, this is just getting sliced 250 times, and we are now seeing a smaller section of that Y axis as part of our smoke. If I was to set this to by size, no matter how big the box is, the voxel size is consistent. So just keep that in mind as you go along. So now if we do a flipbook, this is what we get. Now we also have this small box inside the smoke object box, and that is the gas resize fluid dynamic node. And don't let the name freak you out. All this is really doing is it's cutting down the number of voxels that the pyrosolver is allowed to think about. If the only active area is this small section right here, we don't want the pyrosolver thinking about all these voxels within this container. So that's why we make this gas resize fluid dynamic node. It basically cuts that down and optimizes how the pyrosolver is allowed to think about stuff. And it will speed up your simulation by quite a bit. So with this, the main parameters would be the padding. The padding is how much extra distance does this box have as it's adaptively changing its size over time. We also have this reference field, which is what field is the box allowed to think about when it's drawing the size of this container. Density is good for most situations, and we also have this field cutoff, which basically says that if a voxel is less than 0.005 in its density value, then go ahead and just not consider that voxel as part of the bounding box. So really, between the padding and the reference field, that's the main way in which this works. Now, you do have a few different options on how this gets drawn out. If we go to this max bounds, we have this initialization static, dynamic, from object, and manual. The main two settings here would be the initialize dynamic and the initialize static. What this means is that, let's say we have this be dynamic. If you had, let's say, an object that was moving around in your scene, this dynamic would take a look at this object, and it would basically take however that object is moving around and move the box along with it. So it's dynamically changing its location. If it's static, that means that it's not moving. So in most cases, if your object is not moving around, static will work just fine. You can also use from object, and that will take the specific object that you specify and just kind of follow that as well. Or you can also say manual, which I wouldn't recommend because this basically forces you to manually specify where the box is and how large it gets. So again, in most cases, initialize static or dynamic is what you want. We'll say initialize static. And I also like adding a few delay frames so that this allows our simulation a bit of time before it gets started. So if I say delay frames of 3, that means it takes 3 frames until this thing is allowed to clamp down. We also have this subtract threshold, and this basically smoothens out the motion of how this box is allowed to expand and contract. Most of the time, the default works just fine, but if you were to turn this down to, let's say, 0.001, you'll notice that the movement is a lot more jittery, but we are getting rid of more voxels. If we turn this up, the movement will get a lot more smoother, but we have more voxels than we actually need. So again, I think 0.2 is usually a good way to do that, or maybe a little bit less than that. Let's do 0.1. We also have this tracking object, and what this means is that as this clamps down, this is kind of like a minimum for how far it's allowed to clamp. So let's say that we don't have any delay frames, but instead we can check this. I can specify something in here. Let's say, oh, I don't know, the geometry we made for the steam source, right? Let's maybe go for this out density right there. And this will, when it clamps down, clamp down to the size of this as a minimum. So this is actually a better way to go about it as opposed to the delay frames. You just find an object that's at the minimum, and then that way we're not clamping more than what we need with those first few frames. Okay, so now that you know all about this gas resize fluid dynamic, let's move on to controlling the temperature field and altering the behavior of our steam.